entry? 26. How about for the second? 26. And the third one? So this is one where we could just use 26 to the third because we're not taking away anything each time, okay? So this is an example where we could use an exponential relationship, okay? And all we do is we just multiply those together. There's 26 ways to pick event A, 26 ways for event B, 26 ways for event C, okay? So can somebody tell me if I was to multiply that out, what that would work out to be, please?
17,576.
Thank you, ma'am. So, there's a pretty good number of these that could occur. Okay. What if for some reason repetition was not allowed? Okay. That's only going to slightly alter the number. Okay. So what would we multiply together if repetition was not allowed?
26 times 25 times 24.
Yeah, we just take one of the letters away each time, right? So for the first one, there's 26. For the second possibility, there's only 25, because you've already picked a letter, no repetition allowed. For the third one, we picked 2 letters, so there's only 24. Okay? This is only going to slightly alter it. I think there might be about 2,000 less. You don't get it?
50,600.
What does it mean repetition is not allowed?
Once you pick a letter, then you can't reuse that letter, John.
Oh, the letter. Oh, so
Right.
it's not, it doesn't just mean the code. It
Right.
means any.
Repetition of the letters. Okay. So sorry about that. So maybe I should have been more specific about that. So, but you can repeat the letters that we're using, just not the, or you could repeat the code. But if you pick, if there's only one code that's going to outcome no matter what. Okay. So there's just a one-to-one relationship between what you pick and the output for that. Okay. We're figuring out how many codes there are. We can't reuse a code anyway. Okay. Does that make sense, sir? Okay. So, by the way, how many codes did we get out of this?
15,600.
600? Okay. Thank you. So about 2,000 less codes if we just don't allow repetition. Okay. What if for some reason we allow repetition of the letters but no vowels are allowed? Okay,
20,
so,
21 times 21 times.
yeah, there's 21, 21, 21, because there's 5 vowels, right? A, E, I, O, U. We're just picking the ones that we absolutely know are always vowels, okay? So that would be 21 times 21 times 21. Okay. It's okay. No big deal. And then what would that work out to be? Anybody figure that out?
9,261.
9261.
Yeah.
Thank you, man. And then finally for the last one, if repetition is not allowed, what would that work out to be, guys?
My math is correct, it should be 7,980.
And Greg, how did you get that, sir? What 3 numbers did you multiply?
I multiplied 21, 20, and
Sounds good. And then 7,000, what was it?
980. Yeah.
9,900.
7,980.
There we go. All right. So these are pretty easy, right, guys? That's what a counting method is. And counting, bless you. Counting methods are useful because remember, that's how computers figure things out. They just go one event in order. Okay. So if there's a certain number of outcomes, a computer can figure out how many different ways there are to be able to do that out. Okay. We can do the same sort of thing with the Maryland license plate. Okay, so in Maryland, at least it used to be. Now I think they ran out of license plates, so they now do something different. But it used to be that the plates consisted of 3 letters followed by 3 numbers. And we want to know how many unique or different license plates can be created if repetition is allowed, repetition is not allowed. First letter is a vowel, and the last number is a 0. And the first letter is a vowel, the third is a consonant, and the first number must be 1. Okay, so these aren't too difficult. Let's just go ahead and keep these going. So a license plate has 3 letters, 3 numbers. Okay, so we're going to have 6 spaces. Now we already know that there's 26 letters in the alphabet, and it says that repetition is allowed. So for the first 3, it's going to be 26, 26, 26, right guys?
Mm-hmm.
What about for the last 3? Because they're all going to be in digits.
Well, it has to be
10, 10, 10.
10, 10, 10, right guys? Because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have to make sure that 0 is included as a digit. So it would be 10, 10. Does that make sense to everybody, guys, as to why it's not 999? It has to be all 10 of the digits. Okay. And then if we multiply those out, We just basically tack 3 zeros onto the 17,576, so that would be 17,576,000. So, does that make sense, guys? That it's just 6 possible events, and we're just multiplying, we're using the multiplication rule 6 times, okay? Not meant to be difficult. Okay. If I was to ask you guys for the second one to where repetition is not allowed, okay, now be careful with this a little bit. So what would the first 3 be?
26, 25, 24,
Okay. And then what about the last 3? Would that be
10,
like
9.
8, 7, 9?
no, 10, 9, 8.
10, 9, 8, right? Because we started over with a new unique set, okay? So now we're gonna get 10 times 9 times 8, okay? And that's just because we started over with a new domain, okay? We're not taking away any more letters. We're just taking away from the numbers again. Okay? So we're only gonna get a slight difference between the first and second answer. So if somebody could just tell me what they got if they multiply that out.
11,232,000.
All right, sounds good. So by slight, I mean a little bit more than 6 million license plates that we can't use, okay? So, but they used to be at least, that you could allow to be reuse those. Okay. All right, so for the next one, it says the first letter is a vowel and the last number is 0. We'll assume that repetition's allowed, okay? Unless I specifically say no repetition, you guys can use repetition with this, okay? So if the first one is a vowel, that means the first one has to be a 5, right? And then 26 and 26, because repetition is allowed. So then the next number could be whatever digit it wants, and then another 10, because the second one can be. And then how many different ways are there to pick a 0? One, right? So you don't want to pick a 0 as the last digit, right? Because what happens if you put a 0?
Everything 0.
The whole thing becomes 0, right? And I often see that from students. So, but we don't want to do that. So there's only one way to pick a 0. You just pick the 0. Okay? So, does that make sense, guys, as to why you don't want to put 0 down there? You just want to put 1 there. Okay. All right. And then we just multiply that out. So, was anyone able to figure out the product?
338,000.
All right. So, many, many fewer license plates than before. Okay. And you guys can see, like, just by changing 1 or 2 parameters, that this severely impacts the number of outcomes for this. Okay? All right. For the last one, first letter is a vowel, third is a consonant, and then the first number is 1. Okay? So, we have our 6 spaces. So if the first letter is a consonant, how many consonants are there?
21.
21.
First letter is a vowel.
Oh, it's a, wait,
Vowel.
first letter is a vowel, okay.
Yes, the
So you
five.
answered my question correctly, I just asked the wrong thing. Okay. So the first is a vowel, so there's 5, 26, and then there's 21, because I think the third was supposed to be a consonant, correct? And then if the first number is a 1, how many ways are there? Pick a 1.
One.
Just 1,
And
and the other ones are just 10s, right guys? Okay. So this isn't meant to be difficult, right guys? Okay, you just go through, figure out the number of outcomes, multiply them together.
Easier than the set algebra.
What's that?
Easier than the set
Oh
algebra.
yeah, much, much easier than set algebra. Yeah, because it's just basic computation. And in most math classes, you've been doing basic computation all your lives. Okay. Did anybody get the product of this?
273,000.
Oh, 273,000, and then a bunch of zeros. Nothing extra. Thank you, ma'am. Okay. Easy enough, right guys? We wish the whole examination, that the next exam is going to be all in set theory, or I'm sorry, on counting methods thus far. Okay. All right, guys. So, how many different hexadecimal numbers, and when we say, instead of numbers, we could say words if you would. So, let me scratch out the word numbers, and I'm going to put quotation marks. Let me put words. Begin with a number, end with a letter, and they're 4 characters long, with and without repetition. Okay, so let's just draw our. So we have 4 characters. So let's try to remember a little bit about hexadecimal. Okay, somebody tell me some of the stuff that comprises hexadecimal
A, B,
words.
C, D, E, F, right?
Okay, so there are
A, B, C, D, E, F. 6.
6 letters, right?
Uh-huh.
So there are 6 letters. And then what else is there?
10 numbers.
10 digits, right?
Digits, yeah.
That's That's okay. So, remember it goes A through F and then 0 through 9. Okay, so that's where we have to fundamentally start, right guys? If we don't know that, then we ain't getting anywhere with this. Okay? So, how many different hexadecimal words begin with a number? So that means there's going to be how many to start with? 10, because there's 10 digits. End with a letter.
So 6.
What's going to go in the middle then there, guys? 16, right? Because there's 16 total different characters to choose from. Okay. Does that make sense to everybody, guys? Okay, if we're using repetition, we just default back to the original number of outcomes that are possible. Okay. Then we just multiply this out. And if somebody can go through and tell me what the product is. 15,360. Lovely. Alright. Easy enough, right guys? Not meant to be tough. Okay. What about without repetition allowed? That's a little bit sneakier, okay? But we still have 4 characters.
The first one is 10.
The first one's got to be 10, right? So we pick the first one, it says it has to be a number, so there are 10 numbers.
Second,
Now, do we know what the next one is necessarily? Probably not.
the last one has to be 6, right?
We know that right, but the question is, we still have to think about what the last one is. So
Six.
let's worry about the conditions that we know are absolutely certain, right? So what do we know about the last character? It has to be
6.
what? 6, right guys? Okay, because there's only 6 numbers or 6 letters to pick from.
So the 9 and 8.
It's only 6 if a letter wasn't chosen.
Well, but we're not picking a letter, right? We don't, well, not yet, we don't have to. I'll show you why at the end, okay?
We're forcing us to end it with the letters, we have to.
Yeah, we're forcing
Right,
it.
but it could be number,
Right.
letter, letter,
Could be, yep.
which means.
So then, how many possible choices are there for
Oh,
this?
15.
14.
So
And there's
Delay
13.
number and a letter.
Okay. Doesn't matter what order we pick it in, right guys?
no, it
It's
shouldn't be.
multiplication. What do we know about
Should-
multiplication? It's commutative, it's associative, it doesn't matter what order
Shouldn't
we
that be
pick it
15 and 14?
in. No,
We
sir.
No.
No, we picked here and we picked here.
Oh, okay, okay, okay.
Right?
Sorry, yeah.
So because we've already picked 2, that
That's
means
14.
there's 14 and 13.
Yeah,
Okay? It doesn't matter what order they're selected in, because when we multiply it out, it's going to be the same value. Okay? So what I always try to tell students to do is pick the stuff that you absolutely know is certain, and then start to subtract them. Does that make sense, guys? Any questions? Okay. And then we just need a product for this. So 10,009. Okay. Any questions, guys, I can answer? Okay. And then we can do the same thing with these binary digits, okay? So how many binary numbers, and we could just say instead of numbers, begin with 2 zeros, end with 3 ones, 13 characters long, okay? And A with repetition allowed, okay? So we'll draw our 13.
That's a lot.
It is, but you know what? If you die from writer's cramp, let me know. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's not difficult. So it says that we begin with 2 zeros. Okay? So what should the first 2 entries be?
0, 2.
Nope, not
No,
0.
sorry.
1 and 1, right? Because there's in binary, what is there? There's a 0 and a 1, right? So there's only one way to pick 2 zeros at the beginning. Okay? So remember, let's just make a note here that for binary, the only outcomes are 0 and 1. It says it ends with 3 ones. So
So
what
one.
should the last 3 entries
1,
be?
1, 1.
1, 1, 1. Then what about all the stuff in the middle then? Just a
2.
bunch of 2's, right guys? Because there's only 2 possible outcomes for binary. So it'd be 1, 2, 3, 4, 5, 6, 7, 8. So essentially, guys, doesn't that work out to be 2 to the 8th? And 2 to the 8th is going to be 256? Yeah, maybe. So we go, I guess, 2, 4, 8, 16, 32, 64, 128, 256. Yep. So
And it's 2 just because it's definition.
Oh, binary, right.
is really
yeah,
one.
binary only has 1s and 0s. There's only 2 outcomes. Okay?
Right.
Hence the prefix binary. So 2.
Right, yeah, no, I got like the 0 and 1.
Oh, that's okay.
What you're doing, but it's just
Where the twos are, you could pick a 0 or a 1.
Right, because it says it begins with 2 zeros,
Yeah.
so that's your ones.
Yep.
Ends with 3 ones, so that's that. But it doesn't say anything else about the middle. Middle could be whatever it wants. So it could be a 1 or 0. Two choices. Right, too.
Because you.
'Cause it could be
that's
either
the
a 1 or a
choices,
0.
You're filling in how many choices you have.
Oh,
Yeah,
okay.
You have a choice.
there's 2 choices. It's either a 1 or a 0. Does that make sense?
Oh, right, got it. Yeah.
Okay? Yeah, there's no 2's in binary, but there are 2 choices, okay? We're not trying to make a binary number out of this, we're trying to figure out how many binary numbers there are. Okay? And then probably the easiest question is B. How many different binary numbers begin with 2 zeros and with 3 ones without repetition? None. It's impossible, right? You can't, you have to have repetition, right? So that would be none.
Are we supposed to show all of that?
No, you could just say not possible. Actually, the correct answer would be 0, wouldn't it, guys? Because it says, how many of them are there? Alright, does this make sense, guys? That's what our multiplication rule is, okay? It's not difficult, it just is what it is. Alright, so the last thing I wanted to talk about today was I wanted to talk a little bit about combinations and permutations and use of those. A lot of people think that they're the same thing, but they're completely not, okay? In fact, in general, most applications use combinations, okay? While fewer applications, but some do use permutations, okay? The difference is a permutation order is important in which things are selected, okay? So, let me give you guys an example of a permutation, okay? Let's say I start up here with Adam, and I give Adam $500, okay? And then Angeliki gets $490, and then Paul gets $480. So each time I go through a person, I'm going to give them $10 less. Does it matter what order you are in the class? Absolutely. That is a permutation. The order in which you are seated or you are arranged matters, okay? That's a permutation. Okay? Any of you guys have ever played the lottery? Is the lottery a permutation? Yeah, because